This is OXDF, and today I'm working on Pet the Kitty, the 6th challenge in the 2021 Flare-On. They give you a PCAP, and you have to pull some malware out of it and figure out how the malware works. I'm to the very end right now. I'm writing a script that will pull out the C2 and the PCAP and decode it for me. And so I've actually already got this script. I talk about this a little bit in the blog post. You can check that out for full information. But basically, it reads the PCAP. It pulls an image out of the PCAP, and then it's going to loop through the PCAP, picking up the pieces of C2, and it does a little bit of decoding. So it grabs, the start of it is this always meow. Then there's 2 lengths, which it unpacks, and then the rest of it's data. And then what we have to do, what the data actually is these delta patches, which is a compression format that Windows actually uses for doing Windows updates. They want to transmit the lowest amount of volume they need to update a binary in place. And so here I need to actually apply the patch to that image I found, and then the next time I'll apply the patch to the result. So I just need to keep updating it. And the best way I found to actually apply the patch was this script I found online. Someone's just, it can only run on Windows, so it's importing all these different C aspects from Windows, which is why you see me in a Windows VM today. I don't typically develop here. And it works very nicely. I did some manual, again, I'll show in the post some manual decodes. So what I want to do here is be able to just, over the course of, there's 37 or 33 different back and forths from both the server and the client. I want to be able to apply that. I want to use this library. I could copy and paste this whole thing into my script. It feels like it would just get messy. So what I'm going to try to do is actually import that. If you look up here, actually do import delta patch, and it's in the same directory, so that'll work fine. And I'll get access to all the functions that are in delta patch. And I need to look at delta patch and how can I, at first my goal would be, can I just use the functions in place that are here? And it turns out very quickly I can find out I can't do that. So I'll show how. So if I come down here and look at delta patch, it's got a bunch of arguments, but what it ends up actually calling here, let's see if we can find it. It is right here, apply patch file to buffer. And it passes in a buffer, a patch, n is the length of the buffer, and whether it's legacy or not. So right there, I'm kind of promising. Like, can I just call this same function and have it and pass it in the buffer, and the image is the buffer, and then the patch file I have in memory as well. So is that going to work? And right away I come up here and I can see, well, actually it takes a buffer, a buff length, a patch path. And the first thing it's going to do is open patch path, read binary as patch. So unless I want to save my patches to disk and then open them, which is a perfectly valid hack, but my desire to do things better doesn't like that. So right there I can tell I'm going to have to do some editing. And so in fact, if I come up here and I try to run, let's see, Python solve, let's try to get rid of that, Python solve.py. Right away it's saying, right here, the delta patch has no attribute apply patch to buff. That's because I came over here and I changed it slightly, because I'm gonna change that. So let's come in here. What I'm gonna do is I'm gonna go ahead and take this function, because I want to largely do what this function does. I'm really just trying to change the window dressing or how it's addressed. So we're gonna make a copy of it. And this is the error I showed. We're gonna change patch file to patch buff, and now we have a new function. And so if I save this, I don't expect it to work, but let's just run it, and you can see how the error message changes. Can't decode. So when it's trying to open the file, well, that makes sense. We know that's not going to work. If we come back to where I have my file, I'm passing in patch, which is just the data. And if I look at that, it is a delta patch file, but it's not going to open. So it's not a file path. Let's come in here and start to make some changes. We can get rid of this entirely. Let's see. So what we actually want, patch contents, is actually what we're patching in. So let's put that there, and we'll get rid of this. And we can save it and run again and see what we get. All right, now we're getting some weird stuff. LPC start equals buff cannot be converted to buff. Now, what's interesting here is, and this is something that I've not done a ton with, so it took me a few minutes to figure this out when I was kind of first going through this. I'm importing all these different C types here, and this is all stuff that Windows is using down at the binary level to handle data. That typically Python doesn't use. And you even have these extra classes and structures here. And so what I can see is, let's see, this is happening at line 27 in solve. That is, oh, let's see, where is it in Delta Patch? Line 58. So I come to line 58 right there. What I'm going to do here is I'm going to go ahead and do my favorite trick. You're going to see this in every time I write Python. You're going to see this. Import the Python debugger and then do pdb.setTrace. And what that's going to do is instead, when it hits this line, it's just going to drop me into the debugger. So I can run this again, and I'm in the debugger. What I'm about to do here is ds.lpstart equals buff. So what is buff? Okay, I can see the classes that buff has. That's not what I actually meant to do. I think it's type buff. Let's see if I can do it without typos. It's a class. It's just a string of bytes. So that leads me to ask, okay, what is happening if I call the regular function here? So what I can do is actually come over here, take this, and we'll go down to the same point in the unmodified function that I know works. And now we can call that. So we can say Python delta patch, and the structure for this is, let's see, we'll put the image, there's the PNG in there. The out file will just be trash because we don't care about that. And then the patch, I think I have some of these on here. Let's see, C0, that right there is one of the patches. And so when I go to apply that, now the debugger kicks in at the same place. And I can say, so what is buff at this point? Because it's clearly, okay, it's a C-types class. It's a C-types and it's a C void P. So I need to be thinking in that kind of way. So what I'm going to do is come down here where I'm called, because when I give it this, I give it a file and it's going to read that file. So let's come down here to the arguments where we figure that out. So here's arg's input file, and it's read in as in buff. And then here's the key line. Buff is cast in buff into this win types. So I need that. And since I'm not taking advantage of this main stuff, I'm going to come back up to my function, and let's do it right at the top. We'll come here and we will say, paste that in, buff equals, and we'll just write over buff because I don't think we need it anymore after that. And we'll save that, quit. Oh, let's also get rid of we think that's going to fix our problem, so we'll go ahead and get rid of the debug line, come back up here to solve again. And all right, we're making progress. We are now into Python int too large to convert to cint. That's interesting. So it almost implies it worked, but what I'm guessing what happens here is what it returns is probably not what I was expecting it to return. So we can figure that. Let's address that. Easy enough. Let's come in here. Same line. PDB. PD. And you can do this on multiple lines if you want it to look pretty, but I usually just put it on one line, especially when I'm in Vim. I can just DD and delete later. I actually have a macro set up in my Vim file so that I can just do at P and it adds this line. It goes to the next line and adds this in for quick troubleshooting. So back with that in, we'll come into solve. We got here. So let's see, what is image? Image is what got returned. Now, I was expecting to get back the updated buffer, and what instead I got back was 2 numbers. And I'm not sure what to do with that. So I'm going to go back here, back to this code again. What happens? Okay, so what did I get back? Buff and n. And it does, what it eventually does is it writes out this file outbuff. And to do that, it does these 2 lines. So first there's a toFree, which is an empty array, which is then appended buff. And then there is an outbuff, which is some casting of, it's turning it into bytes, creating a byte array from this stuff. So I think this outbuff is what I actually want. So I'm going to go ahead and grab these 2 lines as well. Come back up to the end of my function. And so right now, paste these into what we got. We need, if we create something called toFree equals, and get that's what we saw below. And now buff is the first thing that's returned. So that's actually, if you come down here, buff is the first return value from this function. So I want is dout_lp_start. So we will append that there. I'll be honest, I don't quite understand what this is doing, but we're just going to try to make the script work right now, so that's what we're going for. So then we have outbuff equals bytes. Here's buff again, so we know that's that. copy and paste there. And then I believe, if I remember correctly, n, we'll come down and double check to make sure, n is the other number coming back. So n is dout.usize. So let's grab this, copy, and put that in there. So now we do just what we did before, and out comes outbuff. So let's just, in fact, we don't even need to save this. We can just return that. Let's get rid of u, because I don't know what those numbers are, therefore I don't really care about using them. And if I run it now, Q to quit, run it again. Let's see, what is image now? Ooh, it still looks the same. Not gonna lie, I'm a little bit surprised by that, because I thought I returned. Oh, let's time to check it. If that's cached somehow. No, it looks like it's definitely there. So image is what's coming back here. Okay, well, again, anytime you're confused, that's where the debugger is useful. So we'll get rid of this here. Oops, and save this. Ooh, Control Z, Control S, and come back over to Delta Patch, and we will, just before the return, put this here and save. So now let's Q to quit, run again. Now it's not. I wonder if we're getting some weird caching here. So I'm going to go ahead and delete the PyCache folder and try running again just to see if that fixes any issues. No, it does not. All right, so where are we seeing this issue? Line 29. How are we even getting to line 29? All right, import pdb. I'm wondering if this is a Windows thing, because I don't usually have this kind of issue here. But we'll get to work through it. I tell you, as someone who writes blogs, typically, it's my gut reaction right now is to stop the video and go figure it out. But I always say one of my favorite parts of watching Ip's videos is when something starts to go wrong, you get to see how he troubleshoots. So I'm going to try to accept my imperfections here and see what we can find. Okay, so we got the call where we're about to call image. We will push S to step into that. And then let's do L and list it out and make sure we've got the version we're looking for. Interesting, it's still showing the old version here. And so that is clearly what's wrong. I wonder, am I in the wrong? Okay, well, so we found my issue. I'm making these changes here to the end of the patch file to buffer. And that's not the one I'm trying to fix. I'm trying to fix, I'm sure some of you were sitting there screaming at your screen that that wasn't the right place. We're going to come up here and we're going to put this into the function that we're actually running. All right. Now we got that, and we can get rid of this. Will just be, I'm going to go try to fix the old function because I, in theory, would like to be able to do this without screwing that up. So we'll put this back here and paste that there. And now, let's say we don't need the PDB problem here. And here I am thinking, blaming Windows when it's really just me being dumb. Let's see. So I'm in patch buff to buffer. I'm going to put this breakpoint right above. In fact, I don't know. Let's live bold. I'm going to comment this out and see if it just works. All right, and here we run. All right, we see we have another error. Errors are things we can troubleshoot. We're on line 27, line 75. All right, let's go ahead and. So, what was my error here? Delta output has no attribute usize. Oh, that looks like a typo. Let's see. Let's see. It was return usize. I'm sure that's a typo. Let's put the E there. Quit and run. Continue. Oh, do this. Let's see. Now, what's one downside here is this function is going to get called over and over again. And so when you have this here, it's going to drop into the debugger every time you hit this function, hit that point. So if you want to get rid of it, you really need to get rid of it. So let's see what happens. And look at that. What I was trying to do is decode terminal output, and this certainly looks like terminal output. So it looks like my function is actually working, which is pretty cool. Coming back up here to the, how far up do we go here? Okay, so this is the top. Right here is where we're running. The first thing they do is they run who am I, they run net user, They start looking around in directories, and if you look through here a little bit more, you'll get the flag. So I guess the point of today was, if you need to modify a file like this, even if you don't really understand all the stuff it's doing, you can use, especially if you can use the PDB stuff, you can really track down, okay, what's my issue? How do I fix it? And cool. That's about it. So talk to you next time. Thanks.